Hey guys, if you are watching this video right now, that means I am no longer working and the long-term sub has not started yet, so you have a substitute. And instead of just wasting this day, we're going to keep learning. So you guys had your Unit 2 test Friday, and today we are starting Unit 3, which is another Algebra 1 review unit with a large emphasis on real world that you didn't necessarily see in Algebra 1. So you guys should all be getting a packet right now that looks like this, and it's going to go along with the very first section on systems, which is learning how to solve systems using 3 different strategies. Today, if you look at the left-hand corner, we're solving by graphing these systems. So we have a table here which is talking about the percent of men who earn an income between 50 grand and 74,999, and the percent of women who earn that same income, and the years since 2000 is the X value in this example. So this scatter plot shows the percentage of men and women since the year 2000, and they have drawn a line of best fit through the data points. So let's just define our variables, since that's the first thing we always do in a real-world scenario. Normally I would say hit pause and go ahead and try it on your own. Okay, but I'm going to keep talking since I'm teaching to an empty classroom right now. So X is going to be the number of years since 2000. And Y is going to be the percent of men and women who are earning between the 50,000 and 74,000 income bracket. So for part 2, it says find the approximate point of intersection for the 2 trend lines and label them as an ordered pair. So visually, we're going to look at our graph and we're going to estimate where those 2 lines intersect one another. Okay, so we're just estimating right now. What would you estimate that ordered pair as? Okay, you can pause and think about that for a second. Pause the video if you want to and talk to your partner. And I will say the answer, which is going to be 8,21. For question 3, we're going to interpret what this means. So what the 8 means and what the 21 means. Since it's the point of intersection, not only am I going to put labels to the 8 and 21, but interpret it even further. So yes, the 8 is referring to the year, and it's 8 years after 2000, so it would be 2008. And 21 would be the percentage of men and women who have earned between 50,000 and 74,000. There's more to it than just that. This point is special because it's when the men and women are both earning the same amount. So in 2008, men and women are at the same percentage. Or I should actually say in 2008, 21% of men and women are earning between 50,000 and 74,000. I should say, I think for some reason the 999 turned into 000, so that's a typo. So you could say just 74,000 according to the label here. After that, they start to separate again. So if we look at this graph, and actually the table, I'm going to scroll up for a second. You'll see that the percentage of men, these percents started higher, and the percent of women started lower. So therefore, on this graph, if men started higher, would men be the red line or the black line? Okay, they would be the red line. So that's men, and this is women. You'll see at the year 2008 when they were the same, that's the key thing there, they're the same. So I want you guys to write that word with part 3. Then women start to surpass men. So women start to earn more money than men, the larger percentage. So if we go to the next page, why the heck did we just do all of that? We started off with a real world scenario. Now I want to focus in on what the solution means. So the solution to a system, which what we just saw was a system. You didn't know it, but it was. A system is any problem that has two or more equations that had two linear functions to it. That is a system. The solution to the system is the point of intersection. So what is the solution? It is the point of intersection. It is when the two functions would be the same. They'd have the same x value and the same y value. We're going to kind of take a step back, and instead of keep doing real world right now, we're going to switch to just reviewing the skills of how to solve a system. So we're going to graph each of them separately and see if we can find that point of intersection. One thing that's going to be different today than what we had done prior is you have to make sure you do the slope a whole bunch of times because we have no idea where these graphs are going to intersect one another. So if you want an accurate graph, you've got to keep doing the rise and run. So for the first one, we have a slope of -3/2 or 3/-2. Second one, our graph has a slope of 1/2 or -1/-2. This is all review from last unit that you guys just tested out of. So that shouldn't be anything new. I'm going to graph line 1, y-intercept of 2, right on the y-axis. And you guys are taking notes with me as though I was here in front of you right now. So you guys are copying everything down into your packets. Then I'm going to do my rise and run, so down 3, right 2. But I'm not going to just do it once. I'm going to keep doing it as many times will fit in this grid. Down 3, right 2. Down 3, right 2. Down 3, right 2. Same thing in the other direction, but up 3, left 2. Up 3, left 2. And I don't have any more room. And go ahead and make your line with your arrows. I'm going to repeat that same process, but with the second line. What's our y-intercept? Hopefully you guys just said 6. And now I'm going to do my slope of up 1, right 1. I'm not going to continue to the right because that's not getting closer to my graph. So instead of continue to the right, I want to go to the left and do this version of my slope. So I'm going to go down 1, left 2, bam, I hit the other line. I'm just going to do it one more time, down 1, left 2, and draw it. Circle that point of intersection, please. And underneath this graph where it says solution, we're going to name that ordered pair, the x value and the y value of that point. So starting back at the origin in the center, that point is to the left 2 blocks, to the left 2, and up 1, 2, 3, 4, 5. So the ordered pair, and I'm going to have to erase this so I can scroll down, is -2, 5. Pause if you need to look at the graph longer. So my solution, -2, 5. Left 2, up 5 is where they intersected. All right, let's try some more. See if I can fit all of it in one screen. There we go. So same thing with all these other ones. So number 2, my y-intercept is -3. My slope is 2/3. And I can write it as 2/3 or make them both negative. Up 2, right 3, and keep doing it. We don't know where they're going to cross. Do it a whole bunch of times. And connect. More slopes you do, the more accurate your line. Second graph, slope 4/6, or -4/-6, with a y-intercept of +2 going on the y-axis. And I'm going to go up 4, right 6, or down 4, left 6. Now they never crossed. What kind of lines would you say these are? Hopefully you said parallel. All right, and they technically were parallel right from the beginning because this slope of 4/6 wasn't simplified. If you divided those both by 2, you would have gotten 2/3, which is the same slope as number 2. And when they have the same slope, we know the lines are parallel. If they are parallel, they are never going to cross. So parallel lines have no solution. They have no point of intersection. You guys can pause the video if you need a couple more seconds to copy that down, and I'm going to erase and continue on. You guys can unpause when you're ready. So for number 3, keep on going here. We're going to have an m of 1/2 or negative 1/2 over negative 1 over negative 2, and the second graph 3/6 or negative 3 over negative 6. Both have a y-intercept of 1. So the first graph, I'm starting at 1 and going up 1, right 2, a whole bunch of times, up 1, right 2, or down 1, left 2. And then my second equation also starts at 1, but goes up 3, right 6, or down 3, left 6. And it happens to be the same exact line. When that happens, they're the same line, they're right on top of each other. They share every single point in common. So we would say that there are infinitely many solutions. They share every point. And you technically could have seen that in the beginning, because if you simplified 3/6, 3/6 simplifies to 1/2. Same slope and same y-intercept, same line. Moving on to number 4, these are special lines. These are going to be horizontal and vertical. Number 4 has a slope of 0 and a y-intercept of negative 4. So you would graph that by going negative 4 on the y-axis, and if it has a 0 slope, it is a horizontal line. So you would just draw a horizontal line through the y value of negative 4. For the second equation, it says x equals 3. There's no y at all. This would have an undefined slope. There is no b value. You go to the x-axis at 3, so it says x equals 3, and you draw a vertical line. We're then going to identify our point of intersection, which is right here. What would be the x value at that point? It is 3. And the y value at that point is negative 4. Do you see any connection between our solution and the equations? You should. X is 3, y is negative 4. It's basically telling you what the solution is right there. The x is 3, the y is negative 4. 3 comma negative 4. But graphically, this is what it looks like. So you would still graph the lines to see what the graph looks like. Okay, moving on. Pause if you need to. My headphone's falling out of my ear here. And we got a couple more. These ones, the equations are not in slope-intercept form, so we have some extra work to do. We're going to take them, I'm going to rewrite them in this empty space. Please do so as well. And we're going to go through and isolate the y variables. First equation, that's easily done just by subtracting x. So y will equal negative x plus 8. Second equation, we're going to subtract x as well. We have a negative y equals negative x minus 2. That's not done because y is negative, so we're going to have to divide all of our terms by negative 1, and we will get y equals positive 1x plus 2. Pause the video if you need another second to write that down, because I'm going to have to erase it to be able to get to the graph. So we have negative x plus 8 and positive x plus 2. Okay, again, we had negative x plus 8 and positive x plus 2 after we isolated y. The first equation has a slope of negative 1 over 1. Don't write the x as your slope. Or you can move the negative to the denominator. And at y-intercept at 8. So 8 goes right on the y-axis. And if I listen to my rise and my run, I'm going to go down 1, right 1 a whole bunch of times. Down 1, right 1, down 1, right 1. It's a negative slope, or up 1, left 1. Second equation has a slope of 1 over 1, or you can make them both negative, and the y-intercept is 2. So 2 goes right on top of your y-axis, and we're going to rise and run. Up 1, right 1, up 1, right 1, positive slope here. As soon as they hit, you don't have to keep going. And if we identify that point of intersection, we have to name the x and the y. The x value at that point is 3, and the y value at that point is 5. So 3, 5 is where they intersect. I'm just going to check something real quick. This one, it says to verify algebraically that that solution works, and we'll come back to that in a minute. That means we're going to do some substitution. If we go to number 6, again, I'm going to rewrite my equations down here so I can isolate y. In the first one, subtract the 2x. You guys can pause, try isolating on your own, and then check up with me when you're done, unpause to see if you get the same answer. Second one's in point slope form, so we're going to have to distribute. You get negative 1/2 x, and then when you distribute a half, you're taking half of 4. Half of 4 is 2, but a negative times a positive is a negative 2. Then we are subtracting the 3, and we will get negative 1/2 x minus 5, which we're then going to graph these two equations. So we have negative 2x plus 1 and negative 1/2 x minus 5. Hopefully I can remember that as I erase it. Negative 2x plus 1, negative 1/2 x plus 5. Y equals negative, oops, I got to scroll down. Scroll down. Y equals negative 2x plus 1, and y equals, was it negative 1/2 or positive 1/2? Negative 1/2 x minus 5. Hopefully that's what it was. Graphing the first one, slope is negative 2 over 1, or move the negative to the bottom. Y-intercept is positive 1. And I'm going to rise and run a whole bunch of times, down to right 1. Keep doing it. Announcements coming on. Or up to left 1.
Williams. Tashana Williams. Front lobby.
What's the slope of the second equation? We got negative 1/2, or move the negative to the bottom. And y-intercept of negative 5. Negative 1/2 means down 1, right 2, or up 1, left 2. Going to the left's not going to help me, so I want to keep going to the right. Down 1, right 2. Down 1, right 2. So they intersected right here, and that is at an x value, I wish my calibration was a little better, of 4, and a y value of negative 7. Okay. So what we're now going to do is talk about how to algebraically verify your answer. So in number 5, we're going to look at the answer we got, and to make sure that it is correct, we're going to sub it back into the original equation and check to see if it worked. So hold on one second, I'm just trying to find what that answer was so I don't forget here. It was 3, 5. 3, 5. So we are checking 3, 5. And I'm going to go ahead and just grab this copy so I have it in front of me. So my first equation, clear this out so we can finish taking the notes. Our first equation in number 5 was x plus y equals 8. And our second equation was x minus y equals negative 2. I'm using the original equation. And I'm going to check our answer of 3, 5, which is an x and a y value. So we're going to sub those in for x and y, and you just simplify each side to see if they are balanced or equivalent. So in for x, I'm going to sub in a 3. In for y, I'm going to sub in a 5, and I'm not going to change the 8. 8 stays 8. You keep simplifying the left-hand side because you don't know that's actually 8. Maybe you made a mistake. But 3 plus 5 is 8, so 8 equals 8. That's a verification. The 8 on the right-hand side comes down, and you simplify the left-hand side until you get a number, and if you did it right, they should match. Not only does it have to work and be a solution for the first equation, it also has to work and be a solution for the second equation. So you have to check both. So in for x, I'm subbing 3. In for y, I'm subbing 5, and I'm checking, does that equal negative 2? 3 minus 5 is negative 2, equals negative 2. It checks. So we were able to verify that, yes, the solution we got from graphing algebraically checks out as well. We have a little bit more of notes, and then we are done with this part today. Okay. If the long-term sub is teaching it, she might start something called the substitution method if there's a lot of time left, just because it's a topic that takes a while to do. So if we have extra time today, we don't want to waste it. So I just want to summarize the different types of answers you can get. First type, you can have the lines cross each other. And when that happened today, we got one solution. We got one ordered pair. Okay? And this happens when the lines intersect. In order for them to intersect, they have to have different slopes. So you could have like y equals 1/2 x plus 2 and y equals 3/4 x minus 7. As long as the slopes are different, they will cross one another. It's when the slopes are the same that we'll have special types of answers. So the next type of solution we got happened with the parallel lines. They never intersected, so there is no solution. And this happens when the lines are parallel. And then we can come up with an example of the equations, and they would need to have the same exact slope, but different y-intercepts. So same slope, but different y-intercepts would cause the graphs to never cross one another. Same slope is parallel, different y-intercepts. And the last case was when the lines overlapped. So you only visually see one line. That was infinitely many solutions. And you would see the same exact line. You could either write the equation twice, or if you wanted to get creative, if one of them was y equals 2x plus 3, maybe multiply everything by 4. So 4y equals 8x plus 12. Those are really the same line, just in disguise. Right? Those would be the same line. One of them is just a multiple of the other one. Okay, and that's it. Right. Again, if the long-term sub is teaching this, you might move on to substitution. If not, you guys can use whatever remaining time that there's left in the period to start your homework. Talk to you guys later.